Hello everybody, hello persons who are here on site, hello those who are looking us through screens. It's my pleasure to welcome you in our seminar for the project Harmonization of Estonian and Latvian Geodetic System in Border Areas, or shorter GeoRefAct. The first, I would like to introduce you the agenda, and I am starting to introduce the introduction. After that, my colleague Ivar Šljepiņš from Latvian Geospatial Information Agency will introduce you the computations, calculations and modeling part. And after that, we will have short question and answer section, and then we will go on with the introduction of the calculators that have been made for internal use at first hand. And if we finish well, then we will have at least 10 minutes for more questions and answers. Later on, for questions, we take first on-site, and afterwards we have made for the Slido. You will be presented the QR code afterwards. So I would like to now start with my presentation. Okay, thank you. First, I will be going some information about the slide. They will be presented in Estonian and Latvian, but I will be talking in English. Questions can be asked in Latvian or in Estonian or in English. But first, I start with what is geodesy? Geodesy is the earth science discipline that deals with measurement and representation of the Earth, including gravity field in a three-dimensional time-varying space. And geodetic reference system is a complete system for precisely describing the Earth using coordinates, heights, or gravity values. The geodetic system serves a basis for spatial data infrastructure, ensuring that all datasets are maintained in common reference system. And geodetic network is a set of terrestrial or satellite geodetic measurements used to determine the coordinates, elevation and/or gravity values. First, now I would like to introduce the project partners a bit. First, Latvian Geospatial Information Agency. It is a national government agency operating under Ministry of Defense, and its main activities include geodesy first, which means acquisition, maintenance and management of geodetic reference system and data, as well free availability of LETPOS reference station network and military tasks. Secondly, cartography and GIS, which has civil and military cartography from scale 1 to 10,000, as well as spatial data management and provision of spatial data services and remote sensing. Estonian Land Board is as well national governmental agency, but Estonian Land Board operates under the Ministry of Environment, and main activities include in the field of geomatics, acquisition and management of geodetic, geological and address and topographical data, and as well spatial data management and provision of spatial data services. And another topic what Estonian Land Board works is land operations, which means managing cadastral data and ensuring its availability to the public, organization of cadastral surveying and control, land reform, management of state's land, and land evaluation activities. Now I go to the Estonian-Latvian cooperation. It is an Interreg program, and the project is harmonization of Estonian and Latvian geodetic systems in border areas. The project period was 2 years, and the main activities has been measurement and computation of national GNSS and leveling networks in border area, local network in Valga, as well gravity survey in northern Latvia. And the results presented today here as well will be coordinated height transformation models, including web-based services. As said, the project partners are Estonian Land Board and Latvian Geospatial Information Agency, and we carry on similar tasks in Estonia and Latvia. And that's why we have been very good performing our tasks in the project. Couple of words about the budget. The budget for the project was altogether 500,000 euros, which was spread to 56% to Estonian part and 44% to Latvian part, and altogether 85% was covered by ERDF or European money, and public contribution was 15%. As said before, the main task was to harmonization of Estonian and Latvian geodetic reference systems. It is known that in Europe all countries shall have the European Geodetic Reference System, EGRS 89, and European Vertical Reference System, EVRS, according to the Inspired Directive. Anyhow, the geodetic system of the countries of the European Union may differ to some extent from European reference systems, and that's why discrepancies exist in height and coordinate values in the neighboring countries, and accurate and seamless use of geospatial data shall be ensured in the cross-border areas. This was what the project is meant for, to see how seamless we can go. A couple of words about national geodetic reference systems. In Latvia, officially used coordinate reference system is LKS 92, established already in 1992 and mainly distributed by Latpos and National Geodetic Network. Latvian height system is last 2005. It was established in 2014 as a continuation of the European Vertical Reference System and is distributed through the National Leveling Network and Latpos via quasi-geoid model LV14. For Estonia, officially used geodetic reference system is GeoRefAct 97, which is the basis for plane coordinate system LS97, established in 1997 and distributed by ESTPOS and National Geodetic Network. Estonian height system EH2000 was established in 2017 as continuation of the European Vertical Reference System, and within the new height system, the new fitted geoid model SGeoid 2017 is in use as well. So we go a bit to the details of the project. We have had so-called 3 stages there. And first, most up-to-date geodetic strategy was used in the implementation of the project, and the methodology included the principles of geodetic data assessment, data processing, and modeling. Secondly, common measurements in the border region were performed, and it did include measurements using high-precision global positioning, relative gravity measurements, high-precision leveling, and as well traversing and leveling in Valga-Valka region. And third, the results of the measurements will serve as the basis for detection of differences between Latvian and Estonian geodetic systems, and transitions surfaces between Latvian and Estonian geodetic systems were modeled based on these differences in the high-precision geodata. And then the outcome will be made publicly available free of charge through the web-based calculation models. The information of that will be provided later on. And the outcomes of the project can be used as a basis for different kinds of infrastructure projects or environmental projects. And we do hope that these outcomes will get good usage in the border region. As every good project is divided to the work packages, it is as well this one. And the work package number 1, called Planning and Measurements. Here we deal with methodology for geodetic measurements, methodology for data processing, and for modeling data models. The second was, okay, I already a bit went through, sorry. And as well there were measurements in the border corridor, different kinds, which are already said, global positioning, leveling, and Valga-Valka. As well, one important for the project was procurement for the equipment, because we needed to procure new equipment to be used to have the good results for the project. And there is a list what we did acquire for the project, and we are happy to have it. And I would not read all of them, but main maybe. There was relative gravitymeter, there was high precision total station, there was high precision level, as well GNSS receiver and antenna, as well one upgrade, but last not least as well some software and field computers. And now some photos, if anyone would like to know how they look like. This, the first is the relative gravitymeter. Then it is a high precision total station, shall be, as we know, one very precise. Then there is the photo of GNSS, high precision GNSS antenna and reference station receiver. Then our high precision level, which was used as well in the leveling works right after the procurement, as well field computers, one for Latvians and two for Latvians and one for Estonians. Four for Latvians, I have seen two. And then it is meteor sensor that was used for the calibration of total station in our Värna baseline. Second was calculation and modeling stage. There were as well different tasks for GNSS data processing, gravity data, leveling data processing and evaluation, as well the connection of local geodetic networks in Valga-Valka region, as well evaluation of geodata differences and modeling the transformation models. And it was as well included in order to check the results with our Varna baseline, the calibration of our equipment in Finnish Geodetic Institute's Nummela baseline. And last, most important one, work package is outreach. This is one what we do here today, but as well it includes the web-based services, what we show you afterwards, and as well seminars. Some words about the timeline when we did all this job. First, we started the methodologies from the first half of year 2021, and we made all methodologies for GNSS, high precision leveling, and Valga-Valka and gravity. And then from May and June we made and we are lucky that we could have this opportunity to have as well physical meetings, because the work done in physical meetings are very many times more successive than through online. And with this, I come to the persons who did the job and who did help. First, for Latvian Geospatial Information Agency, I am not even going to tell all names here, but the most important person is Ivar Sliepins from Latvian Geospatial Information Agency, who did guide the work. Can I say no? No, he will correct it. But from Estonian Land Board, the next list, we have a bit less people working, but more people helping. In Latvia, it was a bit vice versa. So we are really very thankful for all those people who did the actual job and who did help both in Estonia and in Latvia. And I think we have achieved good results. So with this, I would like to thank you for the attention. And there is some photo of our management meeting from Valga last year, and there was as well a nice possibility for our Director Generals to meet. And some working group meeting photos, so we really are happy to meet and see each other. But that will... So, I would like to conclude this. Thank you very much. And for those who are looking from screens, please see the QR code. You can ask your questions through Slido. But those who have here So if you have any questions, so it is time to ask the questions. Now, do you have any questions? Yeah, please. Yeah. Please choose the... Sorry. It's my mic? No? The question was from where what was the initiative? The initiative was that we were aware that there are probably some discrepancies in the border region because we have different geodetic systems available in Estonia and Latvia. And as I showed you in the slide, because there are different initial data which are based for national geodetic initial data which are basis for the national geodetic system, so there are some differences anyway. But we didn't know
Or is some special trick? So, we cancelled everything and go home? Or what we are doing? So, is there some sound? Continue without sound. Now, is there some sound? Latvia, say something. No. There is sound. Very nice. Paldies, Latvieši. So, now there is sound. So, I will then start again once more. Yes, but if it's working or not, it's live or whatever. Okay. So, about project. As I said, measurements on both sides. Some part we did together, some not together, and so on. And it will be at first GNSS, then we talk about leveling and traversing Valga, and some jobs which was done by only one side, relative gravity in Latvia and leveling in Valga by Estonia side. So after field measurements, both sides independently make those calculations and compare them and recalculate and finally get some emitters. We find some small issues, but that's not the big problem. And in Valga there is again this height control, just to know how it is and how it works. So everything starts with methodology, where, how, and how long we need to measure it. That is available in English and will be freely somewhere on web page. Then there will be simultaneously measurements on the border, and other measurements which we need, it's done before or after that border crossing measurements. So that is how it goes. Checking of measurements, yes, all of us have some in-house instructions how to do it. So we did it and check, of course, on the field and compare with values and accuracy. And everything else was just in order weight, calibrate or verify whatever we need to do. So that's how this process goes. So, for leveling, Latvian side use Leica LS15 and Estonian side Trimble DIN03, so there is inward code rods. They have the same accuracy and do totally the same job. The new instruments, quite good working, and we can compare two different geodetic instrument giants how the final results goes together. For Latvia side, we make 9 temporary points. That means we didn't establish any new state network point for leveling. Estonian side did little bit different. They make 9 new benchmarks, 5 in wall and 4 in ground, to do the same job. And all measurements were done as the first order leveling with traditions of 30 years how we can do it. So there you can read, and you all like to read. We have 3 lines for the leveling, where we cross border from both sides. Before we had 4, so quite a lot of those cross-border sections. Mostly, as you see, there's some 3 days before or around the date when exactly we cross. The crossing was done simultaneously by 2 teams from both sides. So it's 1 day, 2-3 sections, and it's done. And after that, to get from the first order leveling lines to the border, each side to what they want, and the days are different because the lengths to the first order leveling lines are different from each side. Yes, somewhere it's closer to Latvia side, the border and leveling line, and somewhere opposite. And some leveling in Valka Valga, which was done by Estonian side. So that is so. Quite tough schedule. As you see, the first crossing is September 17, then it's 21 and 30. So it's small epoch, small time span when we cross the border. So there is no doubt about some land uplift or whatever things what we like very much here in Scandinavia and Estonia, not in Latvia, because we think we are not moving vertically so fast. Anyway, there is no doubts about how good and how nice the results are. They are the best. And those are the lines, as you see, Roza and Urisaari, Uomuļala and Pali Rūpnieki. And before we had the connection Ainuzikla, Valka Valga, and there's a Moisakula. There's a Moisakula somewhere here. Must be one connection more. And that's all, or one more? Huh? And Ape is somewhere here. Yes, and Ape here. Yes, so that was before, and now we have 7, quite a lot, and quite nice. So some pictures from the field works. I have quite a lot of them. As you see, 2 teams, one on one roadside, other on other, and it's quite busy here all around the border at that time. There's some traffic jam, maybe the only people by summer which bears there, but yes, teams work very hard and nice, and already on the border make the checking, so if it's good or not. If you need then remeasured, that's quite easily and quite nice. And yes, this is a picture of both the main persons of the leveling, which done it, and of course instruments, Latvian side and Estonian side. Yes, and we also have some special checking here from the oval, who was checking how we do the job, because I think we interrupt her by sleeping because nobody is doing something by daylight, so we get checked, so this data must be very good. About GNSS measurements, Latvia side use 4 Leica Viva and Leica R20 measure antennas, so it's quite usual and common for us to use them. We use them in daily measurements for the state network. Estonian side a little bit different, like this Pro, Garix, and different little bit antenna, but still it's the same accuracy, the same level, and there's no problem. We have the same amount of 4 and 4 instruments, and we can measure quite fast and quite a lot of data, and in almost one epoch. And each field data was checked in next day, so if there was some problem you can remeasure it, and there of course was problem, and so you can remeasure it and keep continuing some nice traffic. So what was the methodology? 6 hours, 1 session per day. In Latvian side you have 14 sessions, in Estonian side 13, which is separately each done by each side, and then 4 are the common one. Yes, those are the most important because they directly connect both reference system, but what is the main point, the reference frame. With that, all errors and uncertainties which are in the reference frame. That is the biggest issue here. And those cross-border section was cross-border is here, cross-border is here, so it's 4 days in August last year. And before that was some measurements from Latvia side and some extra measurements for Estonia side to check some data and to see how it goes. And this is how it looks. Everything is based on base stations. Those pinks are Latvians and blue are Estonians. You don't ask why the color is so, but Latvians usually are pink, but Estonians are what we want. And you see those points, those are Latvian sides, the reds, and blue are Estonians. Yeah, you can see here around Valka, and after that we will see it's a little bit denser, this network. It's done specially to get the better data for Valka region. And all other is, okay, which are the good points. In Latvia side, it's leveling and first order leveling points and global positioning. From Estonian side, it's mostly global positioning points, which are somehow leveled too. But that is not so important for this reason, because we are obtaining totally new coordinate set in this GeoRefAct project. So Valka, again, if you can see, there's some bird which is checking on Latvian side how it goes. So we are always checked and we know that everything is okay. And then we have traverse measurements, tachymetry as we call in Latvia, in Valka, because as you know, there's one city, 2 countries, or whatever is slogan. But yes, it's static. Twice on each point was measured. 1.5 hour. That is enough for this distance, which is around this Valka. And measurements were done in this main global positioning campaign. Then traversing. Latvian side has this Trimble robot, which is quite okay and quite nice. And if you remember, in leveling we have Lake, and Estonian Trimble there's opposite. We have Trimble and Estonian colleagues have this Leica, something new and fine and very interesting. Yes, it's here. Yes, it's here. So everything, tripods, plumbers, everything is specially bought for the high accuracy measurements. So there is special calibration for them and special certificates that they can keep some kilograms and so on them. How was done the measurement, or did? So 3 full sets for horizontal angles, zenith distance and slope distance. And this was slightly different how we measured, because we measured in each side separately. Valga side is by Estonian colleagues, Valka side by Latvian, is how we measured wall benchmarks. Estonian sides measured 6 full sets from 1 point, and Latvian we measured 3 full sets, but from 2 points, where you have this common side C between those 2 points. We are doing that because that is how we are doing in the local network, not we, but the surveyors, when they need to rebuild local network for municipalities, so we keep the same track. And tachymetry measurements, traverse measurements were done in August, so it's quite a lot of days, 10 days for Latvian and 4 for Estonian. And some border connection in 2 places, one on the road, another one was on railroad. So it went quite good. Now you can see the scheme of global positioning network. This is cut out from this big one where I show you. So there's the points which are in the big one session, and then especially for Valka, and it's Maybe from geodetic point of view, the network is not the best one because it's this appendix is not very nice in geodesy, but still, this is how it's spread these cities, so we need to cover them all. And then this traverse measurement, you see the big line in Latvian side, and then here, and the side of Estonian, and oh yeah, one more connection, somewhere nearby. Ah yes, I know where is it. They was checking from the Director Generals on this line. So it goes, quite a lot of job on information. This is that crossing on the border nearby, yes, this is, I think, Latvian side. And of course, again, we have some checking from the Director Generals, but they are standing opposite. Estonians are on Latvian side and Latvian on your side. So those are Director Generals. So all the time some checking, and after that also. So for gravity, relative gravity measurements, Latvian side use CG5, which we have, some, not the youngest ones, and this new one, both CG6, which is the best on the world, as the company is saying, but it's acting, let's say, it is young, so it needs to rest a little bit. So measurements were done in, let's say, loop system, making loops, so we start and end on the same point, which are spread around in 30 kilometers, and the step is 4 kilometers. So, and the buffer area around from the border of Estonia is 40 kilometers. So, and it's mostly done in this year for this extra checking to know how it goes. That is how it looks. Those black and white, those are network points, second order of gravity measurement. It's measured and established in one set. It's quite normal and useful. And here, yeah, you can see how we try to make this more or less regular grid, and where is, let's say, more forest and nobody living, it's a little bit easier. And where it's more cities and inhabitants, then it's not so easy. Yes, and we measure this appendix, which are usually leftovers in all relative gravity measurements in Estonia side. So we will have homogeneous here too, with a lot of people living, so it's very important place. So from the field, those relative gravimeters are very sensitive, so the tent is used, and somewhere around here it's done measurements relative. So on the roads, the places where it's somehow stable, and you can do the measurements, yes, and something during nighttime, and there's a point one to which you can connect nice lines. A lot of checking from there too. So now about calculation. Those were the measurements. Now will be calculation. And after that, when everybody will be sleepy, I will tell about models, and you will say everything is okay. So we did calculation independently, as I said. Then we compare, check and recheck. Yes, and this was the biggest issue when you are when you cannot meet face to face, because it's very hard to talk what is wrong or not wrong, why it's not so and so on. It's a lot of emails, a lot of those web meetings, but still, when we, those 3 times when we met face to face, we moved very fast forward. At the end, there was one point, 2128, here in, not here, but in Valka, on opposite side, near the guest house, this ground benchmark, which has both heights in both systems, and it was used as an initial point for adjustment. Then after discussion, we agreed that Estonian system and this GeoRefAct, there's no T, GeoRefAct is almost the same in this area because they fit very good. And we decide that the main model will be different between LAS 2000,5 are GeoRefAct those heights. That will we use because those heights we have in Latvia and we can use it for calculations. So that is how it looks those leveling networks. As you see, Latvia has those big loops for first order and Estonia has smaller loops. It's just how it was made. And then with the black is those new connections. And with red are the old ones. And here, Valka in the middle is this initial point for adjustment. GNSS calculations, again, separately, using the same system program, Bernice, which is like standard, more or less, in this GNSS community. What we use as a guidelines, we are participating both Latvian and Estonian side in Nordic Geodetic Commission, which is here in the north part of Europe. And EPN is European Permanent Network, and they have the guidelines how to calculate the coordinates for the permanent stations. So we use them, so use setup in the program which is common for us and used for 10 years. And final adjustment, because before there was, in each of those adjustments, I'm just telling one, but it's at least 10 different adjustments from each side which we have done to get this one something on what we can agree. At first were the LATPOS and ESPOS calculate against European and international base stations, and then all other ground benchmarks were calculated to get those coordinates. Yes, that is how it was done. So at first, to understand and to just remind myself, at first the coordinates are in EGB 14, epoch is 23 of May, and after that we calculate also in 3 extra sets of coordinates, LKS 92, GeoRefAct 97, and the new one which will come in Latvia, LKS 20. But final results and models, of course, are only in official coordinate system, so it's LKS 92 and GeoRefAct 97. And those results were used for transformation, calculation of transformation parameters and the surface. So how it was done? Those are stationed around us, which are in or European or international. Yes, and this is a smaller set, how it looks exactly those base stations which were used in this project. There's at least those two are not anymore in LATPOS, and the same I think in Toratu. There's different stations, but okay, that's no matter. At that time they were there and they were good. So, and after that, this is a network with triangles as independent vectors, as it is done in global positioning. It took some time to figure out which are the best ones. There was some problem in Estonia side, and here there was some problem in Latvia side. Yes, so that is how it looks, but at the end they fit good. Of course, we all the time check heights and coordinates against the state network and different ideas about how accurate is state network and so on. And Valka, again separately, we are doing the job and then compare. Latvian side was using our Latvian program Toponet, which we are using for this kind of traverse calculation, and it's very good. And Estonian side uses like icon. Of course, this least square method, correction from the distance meters, and calibration, and so on and so on. Everything is counted on. Then in Valka, we get this LKS 92, LS 97 in planar, and LKS 20. and final results, of course, are in the official coordinate system. So for Latvian side, it's with coordinates all the time was an extra calculation for this new coordinate system LKS20, which will come someday. And now about the models. Modeling, again, separately is done by both partners, and then compare on the different software we are doing that and checking all the time how it goes. So from the last those adjustment of leveling, we took the heights in Latvian height system and IHAT 2000 GeoRefAct, which is the same for this project, and get some results. And it's so that on Latvian side we have both heights. So in Latvian side it's more or less interpolation, but Estonian side is extrapolation. So it was big issue how to find the best and robust extrapolation surface out from this border of Latvia and Estonia. But then we understand the most important thing is not how the models act against 30 kilometers from border, with those all reference frame inaccuracies and errors come in, but how is the value, what is the value on the border? That is the most important, because that is the place where you meet and what is most important. So we use a lot of program, but we finalized with GMT. They have this surface plane, whatever how it's called, but it's just normal, regular interpolation at the end, which was specially smoothed not to have this step on the border, which could be before. If we use just data from both state network. And here you can see what was the area for modeling. At first it was a little bit bigger. Yes, so that is longitude and that is latitude. And the step is quite small. It's 220 meters, is quite a lot of points. It's dense. And then after smoothing, we get the same model, just smoothed. And the area was smaller, and this area was resampling and get these points after 1.1 kilometer, because this, when you have so small step, the values are not changing at all, they are the same. So we just catch the border when the values start to, at least you can see some parts of millimeter which are changing, and then we fix this step. So that's how it was done. And then the final models and what we will show, they are cut approximately 2 kilometers buffer on both sides from the border. So as I said, the most important are the values exactly on the border. But to have the surface and to use it as a surface, you need an extra points to make some interpolation or calculation, whatever you are using in your systems. And out of the area, those 2 kilometers, there is a none, and there should be no values. At least we are hoping that the system will show like that. So the transformation models, for those, if we evaluate them on the state network, points which are of course with errors, and the model is with errors, are this discrepant are in the values of millimeters. So it's quite good and quite accurate on the border, and it's count all problems for the height which came from EVRS, European Vertical Reference System, from local measurements, from adjustment of the first order network and everything else. So there's the pure errors on the border. That is the most important for using in the daily life. So that is a model. As you see, it's changed slightly in different places. Yeah, here is in the meters, so it's 6 millimeters here are the differences, because this is differences between last 2000,5 and GeoRefAct. So it's not an error, it's a different value what is in the model. Yes. So as you see, the bigger difference between heights reference frames are here, around 1 centimeter. Yes, and here is, let's say, till 6 millimeter minus. Here's plus and here's minus, and here more or less they are seamless, as it should be by definition of Inspire and EVRS and so on. But in the real life, we know that it's not so. And the aim was to accurate height differences on the border. So, and then it's cut, and this is what goes into the all those calculators and so on, and it will be freely available, this cut area as a grid for everybody who wants. He can use not the calculator, but use this grid for some special programs or projects, whatever they need. So, about coordinate, again, both independently to checking, and then recalculate and calculate and a lot of things. We took from the last GNSS adjustment those X, Y, Z for points in GeoRefAct 97 and LKS 92. So we are in geodetic coordinate systems. There's no problems. There's always everything fit good. Problems came when we go to the planar system, and we use transformation parameters to calculate, because 7 helmets as usually in geodesy, those transformation values between both state, national, official coordinate systems, and then makes two models, one for latitude and other for longitude, and yes, evaluate of course them on the state network. So again, there was a lot of models to evaluate and things how to do, and yes, it's in centimeter level, which is very good if we know that LKS 92 is old system, and it has initial problem with 7 centimeters in Y, so its fitting is very good. We know that it's quite impressive for us. And then the transformation is quite easy. We get latitude and longitude in one system, latitude and longitude in other system, and then this very hard mathematical formula, and you can find the differences, and after that use them in transformation processes. So the models for latitude and longitude are the differences, those dB, dL, between two systems. And so you just need, in one system, you just need to add, and to go from LKS to best, you just, to get the LKS from est, you need add, and opposite. From LKS to get est, you need minus. And there's no problem. Again, we use the GMT tool, the same surface spline algorithm. It's quite okay. And area is the same as the final for the height. Yes, and step, as we before find out, this 1.1 kilometer is quite okay and quite nice, and it works and it's okay. So that is how it goes. And again, buffer 2 kilometers from border, everything else out is none. And yes, and this model fits this in 1 centimeter level on the state points with all errors. So this is latitude, full, yes, which you see it's changing as it should, yes, and then it's like this on the border, yes, and some those differences. And the same for longitude. And on the border, yes, it's a little bit different shape because it's different axis. And at the end, you get this nice model. Yes, so. And Valga, which is another approach to the same problem. In Valga, we get planar coordinates in L-est and L-est. As you know, we have different projections. You have Lambert in Estonia, and we are Transatlantический Mercator in Latvia. And you have those extra 6 millions on y-axis. You have those extra 6 millions. We are living without them. So that's, but it's maybe problem when you are calculating by hand, but if computer is doing that, there's no problem. Anyway, as the first step, you have this 2D transformation. It's not transition, let's say, more just to fit those coordinate systems on those latitude and longitude, where there's no different what is planar coordinate system. And then you add you have those differences, latitude and longitude, and then you made the differences on those grid points between two planar systems, coordinate systems in planar, and you have a nice grid. And we try to do it for the whole area of the border, but due to the scale factor, it's very hard to exactly calculate, and you are using accuracy of the model. But in this area, which is Valga, you can make this kind of magic and have the difference on the plane. So on the planar system and on the plane. So model area is smaller, of course. Steps are smaller, and so more points. Of course, the area of Valga is not so big. And yes, and if we compare geodetic points, which of course we need to understand those geodetic points need to be in good shape too, then it's millimeter level, so it's very good for here. And so you can see this is in X, and this is in Y. For Valga, yes, it's quite robust and quite nice. How is the change? And that means that in this area Valga, we have, from the models, we can get directly planar differences, and it can easily calculate it. If we are looking back to those models, no matter if it's latitude or longitude, at first you need, for example, planar coordinates, which are mostly used, get to the latitude and longitude, then add or minus, and then go back. So it's more few steps, but it seems it's quite good working with nowadays machines, so we don't need to do it by hand. So, yes, something else. As we always need to say that we have this LATPOS for free, not like in other countries. In Sweden, for example, you need to pay. We have statistic of LATPOS real-time kinematic those connections. We are collecting them all the time for some reasons. And here you can see February, when usually is not so many collections. Mostly they are surveyors, and it's something about 24,000 connections per month from surveyors in the winter time. But it's the same in summertime, so all the time the same connections. The buffer is 10 kilometers around the border, so the green are agriculture, the yellow, it should be orange, surveyors, and pink is others. So you can see that there's some surveyors doing something in February, there's some agriculture in February, and others, and here's the Valga, yes. And total amount of connection per month in this area, yes, some Estonians, 365. Yes, so it's not so many users, but as you see, there's somebody near here too. And this is August, and the biggest user of the LATPOS data, if we watch through the year, of course, is agriculture. It's in the April and May the one spike, and August and September is another spike when there's working all the time, all day and night, and so on. And as you see, there's a lot of agriculture. So from Latvia side, there's some rich farmers with the good tractors, which are using LATPOS. Yes, so for this precise agriculture. So there is users near this area where we suppose this final results of GeoRefAct are useful, but they are mostly agriculture. So, yeah, but here you see some road reconstruction, because those lines usually shows where the road reconstructions and agriculture are mostly in some bigger bunches. Yes, here some road reconstructions, and so on. And as you see, those dots, tick, 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 which are regular, those are agency measuring relative gravity measurements. So those are we. So that's all. Questions? Karin, could you please move this slide on? I lost it. Please, questions? Latvians? No questions? Yeah, there's a question. Where is Janus with microphone? There's no microphone.
I can be done. I have a question to both of you, to Karin and to our Latvian colleagues. If we leave aside corona restrictions and impossibility to meet face-to-face, what was the biggest challenge or maybe some kind of issue you faced during this project?
For us, that was this procurement for relative gravimeter, because it was, let's say, due to corona, we paid some 20% more than this instrument must pay. And of course, we at 2020, when we put this project on the table for European money, we didn't count for that. That was a big issue for us. That's why we cancelled. But there was no problem with some border guards or railway administration or whatever. Everything was smooth, and before we had a good cooperation with Estonian colleagues, so we did nice professional job. For us, it was really great that we can do real geodesy from the bone, and that's at least I didn't face anything much.
No, I don't think that we did face any huge problems. The everyday problems which occur, but not really the problems until now. And I have one question, is in Slido, at least one. In the future, would we expect more synchronized and common geodetic system for Estonia and Latvia? That's for you first.
No, of course not. National system is national system. Yes, yeah. It's like army. If each has each army, and it will not synchronize till the bone, never. So it will be the same. But this project and models allow us to feel on the border that they are synchronized totally.
Yes.
At the moment.
At the moment, the border is synchronized, but there will not be. Techniques not working always good. So there will be, as Ivan said, the national system is national system, and as it is based on the data acquired within the country, so they will be always different.
Yeah.
But now we haven't shown that there is at least something synchronized.
Yes. Yeah.
Yeah. Do we have some question from audience more? I don't see hands. Okay.
Something Slido?
No, not yet. I don't. Well, let me see. No slider. No.
Anyway, if you have questions, then write to us. After that, we will publish this everything on the web and the questions and answers, and there's no secrets. We will tell everything what we can tell.
There is one in Latvian.
Yeah. So Viesturs, hello, yes, he's an ex-colleague of us. He's asking, can we manage to make more than we suppose or wish? No, we just tight on the border. Maybe if we have no COVID, then we would finish earlier, for example, for this modeling for sure, and then we could do something more. But now it's only what we were supposed to do in the project, no extra. Because there is a lot of geodetic information and good measurements which allow us for the future to do something more from geodetic perspective.
Yes, definitely, for the future, but within the project, everything as planned.
Yeah.
Okay, we do not have any other questions. So then we would go on. We have 15 minutes early now.
Yeah.
Nobody wants that. So we would go on with the calculators presentation for Estonian part.
Okay.
Yes, calculators. I would tell about the calculators now and from Estonian part. First, we are presenting a numerical calculators which are available from our new web page. Estonian Land Board has launched in the June this year a new web page for our geodetic point database, and it is available from this address. And there is calculators, and at the last three will be the calculators from this project. This is not available at now because it still goes with the validation and security checks, but the calculators will be freely available from 15th of December. We expect to have all validation and security checks done by then. But there will be which one first is for coordinates, then is for Valga-Valga coordinates, and the last one for heights. And I will show you how it is working. But before, it is all same for all our calculators. There is possible to calculate by three possibilities. One is by 1 point only, so you enter for coordinates or heights for 1 point, and you get the answer for 1 point. And there is another, if you can upload the file, and you get the file with all information, or you can have several points through the form, but I'll show right how it is working. So first of all is how it is working for Estonian and Latvian height systems. So if you enter here the coordinates, and you can have here either Estonian coordinates or Latvian coordinates, either in plane coordinate system or geographical coordinates. So no difference. The answer always will be there, right one. And as example, I have inserted Estonian LS97 coordinates and the height in Estonian height system EH2000. And if you then hit here compute, There you have the answer for the height. So in Latvian system, the height value will be, yes, about 10 centimeters more. So this is how it is working, for example, for 1 point. And there is another, if I want to calculate from LAS 2000.5 to Estonian height 2000, so I here enter the Latvian planar coordinates and the height in Latvian height system, and I have as the result the height in Estonian height system. So that is how it is working. So, but if I accidentally go from the area where the model is not working, so I got the message here. So it is outside the model area, as Ivar's told beforehand, as it should be. So you don't have to worry if you don't know where the model area ends. So the calculator will tell you if you are outside the model area. And the next for coordinates. And if we have coordinates, for example, in LS system and we would like to have in LKS, so we enter as 1 point coordinates and we have the answer here in this way. Or if we would like to have a file here where I have just chosen from my computer one test file what I had available in LS97, and you have to see there is some information that file has been uploaded, and then if it's computed, so you can download the file here. So it is working as one way or another. And there is, of course, if you are using file, you have to see what is the structure. This has to be seen. And another way, if you would like to go through form, you just enter the coordinates. I am using now this transformation from Latvian LKS 92 to LS 97. You enter here several coordinates, and then you get answer as well in this way. So. And in Valga, it is working as well. The same way, but the model are a bit different, as Ivar told you, for the overall coordinates or Valga, because we use different input and output, but the calculator looks almost the same way. Yes. Do you have any questions about that? No? No? Yes?
Is there possible to add a file of coordinates several for this calculation?
You mean file with file? Yes. If you can add as well file and upload it and then it computes. You mean that one? It is in CSV, Excel CSV format usually it now uses, but yeah. We are, as one thing what I didn't tell yet, one thing, we are planning to have it in English version as well next year. It is listed for our IT company to help us to translate into English. So now it is only Estonian, sorry for Latvians, but you improve your Estonian skills. But yes, next year at some point we will have it in English as well. Yes, but it is possible to upload through the file, and then you can have uploading it as well afterwards downloading. Yeah. On Slido? I do not have anything in Slido yet. So, can we have now the calculators for Latvia?
So, I hope everybody hear me. So, for Latvia, no, not yet, but we have a little bit different approach. But anyway, it's do the same. That is the most important. Yes, this should be mine. So we have the map browser, where you can see all data, what you can get from agencies, partly for free, partly not. And yes, this is a Cartes' map, and LG and Go and everything else is just in English. And we made this like a little bit more for not so educated in national languages. So if you put this one, this is something like book, you can see everything what you can get and change the map, base and so on, so whatever. It's very nice. And then you choose this Earth symbol, and then you have possibility just zoom where you want, put orthophoto or whatever. Yes, but then it makes like this nice dropout where you can choose LKS 92 or LS 97, whatever you want. And here in Valka region we will do some exercise, yes. And then you choose this pinpoint, yes. You do nothing else, you don't know what is a coordinate, you just need to know what is a coordinate or different of heights in the system. Then you point it somewhere, and directly when you will point it, it's in LKS 92, if there is a values, then everything is okay, you are on the area of the this model, and here you have coordinates LS 97 directly. You don't need to do anything else, nothing to write or whatever, and you need to, but for the heights, this is taken directly from this coordinate model, and it will be the same for the whole border, but we are not so fast as Estonians. We have only now for the Valka and Valga coordinate transformation. It's not transformation, it's transition, and for the heights. But if you choose, for example, LS 2000.5, because you can choose to this Baltic height system or Estonian height system here and write some numbers, and you will have the same coordinates and the height on the Estonian height system. And it works oppositely if you will choose here LS 97, it will do the opposite things and so on. And if you are out of the region, then in this place there will be written that you are out of this region, or there will be some signs. That is how it will work, yes, and this opposite, yes, LKS 92 here, but change height and it works opposite direction. So that's all what you need to do. Just pinpoint, choose a place, and do whatever you need. So that is how it will work for Latvian side. I think will not be on 15th of December, at least Latvian side, but in January it will be, because we have a little bit longer this security check due to that we are under the Minister of Defense. So that's all, but it will work like this, and we are still thinking, do we need this file upload or don't we need? Because this transformation to get to use those models, it's very specific task, and those cells are, as you see, in one model is 1.1 kilometer to 1.1 kilometer, and here in Valka Valga it's 220 meters. So we need to see, do we need it like that we upload some files or not, because it's not written in the project, we can choose. But anyway, we will give these models for free to everybody, so you can do what you want in your system with this grid data. But that is how it will work for us. You don't need to know anything about Latvian language. You just need to know the web page, symbol, and abbreviatures of coordinate systems and height systems. And then you can do whatever you want. You can put, say, orthophoto back or whatever, and you will get the same results everywhere. That's how it will look for Latvian side, hopefully in January. So,
Okay,
questions?
thank you. Now questions. We have half an hour for questions. Everybody has to ask at least 2. Yes. Dear guests, be here, please.
Everything is understandable. And as you see, all results, as I was joking, it's just one symbol of the Earth and pinpoint, and that's all what we did. And something is changing here, here, and here, and that's all. And two years of measurements, calculation, and modeling is ended in something that you cannot see, which is just doing some automatic things.
So usually things which looks like easy, there are quite plenty of work behind it, as it in this case. So please, dear guest, you can ask as well in Estonian. We will translate. Do not worry. No, I don't hear anybody asking.
Slido?
No, nothing in Slido.
Nothing. Everything is understandable.
So that means we have been very clear and everybody understands very well, or nothing is understandable. I hope the first one.
So, really, please, all kind of questions.
Really all kind of.
Yeah, almost. We can always say that it's secret.
Okay. In Slido there is no question.
Then, we say thank you.
We say then thank you for coming. We hope to entertain you 2 hours, but it is now 1.5. So thank you for coming. Thank you for being with us here. I think it has been very well spent 1.5 hours. And once more, thank you for the project teams for their work, what they have done through these 2 years.
Yes, thank you for teams, thank you for coming, thank you for those which are on opposite side of the glass and watching us. Yes, so please use which need, and as I said always, the emails, write us, we will tell how it's worked, how it's done, and how all questions about the project. So, thank you.
Thank you.